So this question says that the volume of a box is given by x multiplied by 100 minus 2x times 70 minus 2x. So what we want to do is we want to define that in our calculator. So maybe we can call it v of x. So let's do x multiplied by 100 minus 2x multiplied by 70 minus 2x. If we interactive, define, and let's, for the sake of it, call it v of x, because the volume of the box is a function of x. So the side lengths of the box, x, or the height of the box, or whatever it is, whatever x represents, determines the volume of the box, depending on what x is. So you can see how the volume is a function of the as a function of x. So if we press OK to that, it's done. And what we want to do is we want to go and graph it. So if we go menu, graph and table, let's clear everything there. Okay, let's graph v of x. And we're just going to have to set the scaling. So, you can't have an x value less than 0. And maybe, I don't know, the x values go up to, let's just take a guess, 100. The y minimum is going to go from 0. This is our volume values now. I don't know, maybe it goes to 1,000. Let's see if that works. Okay, that wasn't very good. Looks like our y values aren't big enough. So let's make y 10,000. Oops, that's the minimum. So 0 to 10,000. Still not great. 0 to 100,000. And I did the same thing. 0 to 100, 1, 2, 3. There we go. It looks a bit better. So we have a situation where the volume of the box changes depending on the x values. So if we were asked, for example, what is the x value when the volume of the box is 6664? Let me just make sure that's the right value. Yeah, so for argument's sake, we want to know what is the x value when the volume of the box is 6,664 centimeters cubed, let's say. So what it's essentially doing is you're drawing a line at the volume. So when the y value, remember our y values are our volume values now, is 6,664. And then you're going to see that there's 2 times when that's true. Now, this one over here is not going to count because you can see that after this point, our volume goes off to infinity for our box. Now, unless we have infinite material to make a box, we're not going to be able to get volume values that go off to infinity. So the only part of the graph that we're actually interested in is from here, the volume increases with changing values of x, and then to here, where the volume goes back to 0 again. So what we can do is we can do analysis, G-solve, intersection, and we can see that when the x value is 1, we have a volume of 6,664. And when the volume is, and it's a bit hard to read there. Yeah, when the volume is about 32, I think it says. So obviously it's a bit hard to read this. What we can do is we go back to our main screen and we're going to solve v of x. So v of x equals 6,664. Interactive advanced solve. Okay. Okay, and we get 3 solutions, which we saw. We had the line where it hits 3 times. One of them's no good, but let's just put this to decimals for now and press enter. Okay, and that's what we said. So we get one solution when x is 1. We get another solution when x is 32.10. But that's this solution. So it's these 2 solutions. This one is too big. You're taking out too much of a cut of the box because you can only have certain x values, and you can see why. If x was 51 and I put that in here, 100 minus 2 times 51 is going to give me a negative answer here. Sorry, not this. Yeah, this part would be negative, and basically that 51 answer is no good because you've only got a certain amount of material for your box. So yeah, your 2 answers are x equals 1 and x equals -7 multiplied by the square root of 2 plus 42. Hopefully that makes sense. You need to reject the other answer. You need to provide exact answers as well, unless it says otherwise, unless it says to 2 decimal places. So you need to provide these 2 answers.